The first distributed file system mechanism we will look at is caching. Caching is a general optimization technique in distributed systems where the clients are permitted to locally maintain a portion of the state, in this case, portions of the files or file blocks, and also the clients are permitted to perform some operations on that cache state locally. For instance, some of the open or read or write operations can be issued against the locally cached files or file portions. This can be done potentially without contacting and overloading the actual file servers. Keeping the cached portions of the file consistent with the on-server representation of that file requires that we have some coherence mechanisms. For instance, in this illustration, clients 1 and 2 both cache a portion of the file f. However, client 2 has subsequently modified that file, f', and has also updated the file server to reflect those changes. The question then is, how and when will client 1 find out that client 2 has performed these changes? The problem here is similar to maintaining cache coherence in shared memory multiprocessors. There we said that we use mechanisms like write update and write invalidate, and these mechanisms get triggered whenever a particular variable or a particular memory location gets written to. What this would mean in the context of this example that whenever client 2 performs any kind of update to some portion of file f in its cache, that will be propagated to client 1, either as a write invalidation message or a write update. The actual change will be visible here. But given the very different communication costs and also latencies that exist in distributed systems, achieving this may not be realistic, and also it may not even be necessary given the ways that files are being shared. Instead, for distributed file systems, things that make sense would be to trigger some of these coherence mechanisms on demand when a client needs to access a file, or periodically, or whenever a client is open. And when exactly get executed will also depend on whether the coherence mechanism is something that is client-driven, so the client initiates, I need to find out if the file is updated, I need to see the new version of this file, or server-driven, where the server notifies the clients that have cached the file, in this case client 1, that something has changed about their cached state. The exact details of how and when the coherence mechanisms are executed have to be such so that the file system can maintain consistency guarantees. However, what those details will be will depend on the file sharing semantics that this distributed file system needs to support.